All right, so continuing partial fractions, I'm going to just give you an example to try, and then I'll kind of expand on what we did a little bit in part one and add a little bit more to it. So let's say I've got 3x plus 4 over x squared minus 4x minus 32. See if you can rewrite that using partial fraction decomposition. This is 9.4 stuff. So remember, the first thing you want to do is factor the bottom. You might want to have your notes out with an example. I'll give you a couple minutes to work on it. So hopefully you got this far. Can somebody tell me what to do now? Good. Multiply both sides by this denominator right here. So you're going to want to multiply both sides by x minus 8, x plus 4. So when we distribute, these will get divided out. It'll just be a 3x plus 4. And these x minus 8s will divide off, so it'll be a times, focus. X minus 8s cross off, so it'll be a times x plus 4. And then b times x minus 8. So then we need to set up system of equations. We do not have any x squareds, but we have some x's and we have some numbers. So for the x terms, I have 3 on the left side, and I have a plus b on the right. And as far as the numbers go, I have 4, and I have 4a minus 8b on the right. So 1, 1, 3, 4, negative 8, 4. We do reduce row echelon on our calculators. Somebody have an answer? 7 over 3 and 2 over 3? Okay. Do we agree with that? Okay, so 7 over 3 and 2 over 3. Remember, that's what our a is 7 over 3, so it's 7 over 3. And then 2 over 3? Okay, thank you. Okay, we rewrote this right here as partial, using partial fraction. All right, questions on that? If they were all that straightforward, be in pretty good shape. So expanding on that, we learned that yesterday, I talked about a little bit. 2x squared minus 6x plus 1 over, let's say I have we always have to factor the bottom. If it's not factorable, it's not a partial fraction problem to do. So this factors to be, well, I can take an x squared out. That's what it factors to be. And if you remember, if you have something of degree 2 or 3 or a different multiplicity, you have to account for all degrees of it. So I'm going to put an a over the x squared, and then I'm going to put a b over the x, and I'm going to put a c over the x plus 4. And if this was x cubed, I'd need 1 over x cubed, x squared, and x to the first. Why don't you just get to this point and then multiply both sides and stop on this next problem. Let's see. So just set it up and then try multiplying both sides by the denominator. You don't have to do the solving the system. Just maybe do the first couple steps of this one. All right, so factoring out x cubed, I'm left with x minus 3 in the bottom. So I'm going to do a over x cubed, b over x squared, c over x, and d over x minus 3. So now we have to multiply both sides by our denominator, which is x cubed times x minus 3. So these divide off, so 4x squared plus 2x minus 5. These x cubes will cross off or divide out, so it'll be a times x minus 3, b times x squared, and two of those x's are going to go away, so it'd be bx x minus 3, c x squared x minus 3 plus dx cubed. And we'll call that good enough for that problem. How many got something close to that? Close-ish, huh? That was a pretty hard one. But you understand that you have to work your way down. If you're going to set up this system of equations, we have x cubes, so you're going to have an x cubed, x squared, an x, and a number or constant. That is going to be a 4 by 5 matrix eventually if you're asked to solve that. If you have dx cubed on the right and no x squareds on the left, you're just going to have to do 0 for this side if there's x cubes on the right side. Okay, so that's one exception if you've got a repeated factor. I have two more things that we need to keep in mind. If you have something like 4x squared plus okay, this one's going to be a little bit different. We still factor. Is this not? Okay. The screen stops and I'm wondering if it's recording or not. All right, so you factor the bottom. This time we can only take out an x, so I'm x squared plus 5. So we do an a over the x, but this is a non-factorable quadratic factor here. You can't factor x squared plus 5. So what you need to do is put a b x plus c above it. You have to have a linear top or numerator if you have a non-factorable quadratic. Okay, and then you do it the same way. The process is the same, but that's just one thing you have to keep in mind. So see if you can get to just this stage. I'll give you another example. You want a hard one, or I'll give you an easier one. All right, it's almost the same thing. See if you can just set it up. Okay, if you happen to put the x squared plus 2 first here, it would just be an ax plus b. That'd be an ax. If this was first, just do an ax plus b, because you have to have the two letters on top, and then c would go over the x. You're going to end up getting the same answer. All right, so far so good? Exciting stuff? All right, so last type of problem. This is going to involve maybe a groan, maybe a, oh, I can't believe we have to remember how to do that. We have, if you ever have, let's see, 2x cubed plus. If I was going to rewrite this, if you ever have the top the same degree or bigger than the bottom, this is x to the cubed. Everything up into this point has had a larger degree on the bottom. If the top is the same degree or if the top is bigger, you have to do polynomial division. See, you're too polite. You're all groaning on the inside. I know you are. Okay, remember, if there's no x squared, we have to put a 0 in there as a placeholder. And I might as well just kind of walk you through this, and then I can have you try one. So x squared goes into 2x cubed. X squared times what is 2x cubed? That would be 2x. And then you multiply this times all three of these terms, so 2x times x squared, 2x cubed, plus 2x squared, minus 6x. And subtract. Those are gone. 0 minus 2 is negative 2x squared, plus 10x. Minus 1. So x squared goes into negative 2x squared minus 2 times, so negative 2x squared minus 2x plus 6. And then subtract. Gone. 12x minus 7. Okay, so what we've done is we divided this into this, and we get 2x minus 2 plus, and this is my remainder. I put that on top, 12x minus 7 over whatever we're dividing by, x squared plus x minus 3. So if we were doing this problem, we would divide them. This is what we have now. We divided them. So we get 2x minus 2 plus, and then you have a rational expression that you would probably have to do partial fractions on. You go through all that just to begin the problem of partial fractions. We're not going to finish this one. It's not even factorable on the bottom. I should have made one up that's factorable. But you do this, your answer is going to be 2x minus 2 plus whatever you get when you do partial fractions. All right, so for old time's sake, I'll have you try one, or at least try dividing. Why don't you try see how far you can get with this. Start by dividing, and then you don't have to do I think we know how to do partial fractions right now, so just start by dividing and then know what you would do next. Go ahead, I'll give you a couple minutes. All right. So x squared goes into 3x cubed, 3x times x cubed, 3x cubed, minus 3x squared, minus 36x. That's gone, plus so 3x squared, plus so that's 30x, plus 1. And x squared goes into 3x squared 3 times, so 3x squared minus 3x minus 36. Subtract. And bring down the plus 1. Oh, I already brought down the 1. Don't need to bring it down again. Alright, so there's my remainder. 33x plus 37 over our trinomial x squared minus x minus 12. Raise your hand if you got that. Good. Fair amount, quite a few people actually. Okay, so if we were given this problem, you understand that we have to now do partial fractions with this one, right? And then whatever you get for an answer, just do 3x plus 3 plus whatever we get when we do partial fraction. That'll be the whole answer. Yeah, we can call it. Do you want me to show you synthetic division real quick? You don't care. If I had like x cubed minus 2x squared plus 4x minus 1 over x plus 5, that's when you have negative 5 out front. 1, negative 2, 4, negative 1. This was easier than polynomial division. You probably won't bring down the 1. Multiply, add, multiply, add, and then multiply. What's that? 195 or something? Negative, and then add. So there's my remainder. You probably will not have synthetic division, but it was a good refresher.